everybody, welcome back to yet another video. In this video we're going to be walking through the infamous question 58. It's a tough one. From test 1, the math test and test 1, your red book. So take a second, pause this video, read over number 58, take a look at the picture, and then I'll walk you through how to solve it like a champ. Great, now the reason that I call this question the infamous question 58 is because I know it's a pretty tough question. We're going to have to deal with, the way that circles work. We're going to have to deal with some trigonometry. We're going to have to deal with some pretty messy stuff. But we're going to attack this whole thing in the context of a word problem. This is really a word problem, and we're going to treat it as such. So in our word problem strategy, step 1, as always, what are we trying to find? Well, in this question, they want us, if you read to the very end, they want us to find the length of AC. And AC with this little rainbow looking line over it means the arc AC. And what an arc is a piece of the circumference of a circle. So the distance around the circle from A to C is the arc AC. I'll underline this in green so you know that that's what it's talking about. That is what the arc is. We want to know the length of that arc. Now, we're going to move on to step 2. What do we know? What do we know, okay? Well, we know, of course, everything that they give us in this picture. We have a circle with a center at D. It has a radius from D to C of 4. If we drew a right triangle, if we went straight from point C on the circle down to AD, it would form a right angle, and the distance from B to C is 1. It gives us all of this stuff in the question. And we need to use this information to find the arc length of AC. Now there's something very important that you have to know. You have to know that arc length and central angle measure are best friends. What I mean by that is, in order to find the length of an arc, you have to know something about the central angle. And the central angle is this guy right here. It is an angle formed at the center, with the center of the circle as the vertex of that angle, with 2 radiuses coming out of it. Radii, I don't know, something like that. This is our central angle. And that central angle is going to tell us a whole lot about the arc length. They go hand in hand. In fact, if we want to move on to step 3, we do so in the following way, okay? This is where things go from, we're using our word problem strategy, it's a walk in the park, we're picking flowers, everything's fine, to, this question's a little tough. What you have to know is the fraction of the entire central angle, which is always, there's always going to be, if I was going to extend this all the way around, there's always a total of 360 degrees inside of a circle. Now the fraction that this little pi piece takes up out of 360 is going to be the same fraction that the arc length takes up out of the entire circumference of the circle. Okay, that is why I say they're best friends, because one determines the other. So if we want to find the arc length, we've got to know the central angle. Or if we want to find the central angle, we got to find the arc length. So we got to find the arc length. Let's look for the central angle. We can find it, believe it or not. So here we have a right triangle, right, with an opposite side of 1 and a hypotenuse of 4. We want to know this angle. I'm going to call this central angle theta. Okay? So if we want to find theta, we can use some trigonometry here. Since we have the opposite and the hypotenuse, remember, SOHCAHTOA tells us something using the opposite and the hypotenuse. So if we have sine of theta equals, opposite of hypotenuse is 1 over 4. All right, we're getting close to finding this central angle. If we know that sine of theta is 1 over 4, we can actually solve for theta by taking the inverse sine of both sides. Okay? So this would be the inverse sine. If we take the inverse sine of both sides, well, the inverse sine of sine of theta, okay? Now if we have sine and then we do the inverse of sine, these are going to cancel out and you'll be left with theta equals, we're taking the inverse sine of this side as well, theta equals the inverse sine of 1/4, okay? And if you look, I want to be very clear, we have to be very careful with this. We also know, if you read into the question, it's very clear that you're going to be working in degrees, not radians. So we're going to be in degrees. So here's what we're going to end up having. We know that theta is the inverse sine of 1/4. And if we want to find this arc length, I'm about to give you the formula for arc length when we're working in degrees. So here it is. It's going to be arc length, which I'm going to call AL, equals, all right, the measure of the interior angle, the central angle here, the measure of this angle, which we know is angle CDB, over the entire central angle, which is 360 degrees. Remember, we're looking at the fraction of our central angle over the entire central angle. So the central angle over 360, that's the fraction. So arc length equals that fraction times our circumference. We take the circumference and we multiply it by the fraction right here, we will get the length of that arc. Because the fraction of the central angle to the entire 360 is the same as the fraction of the arc length to the entire circumference. I know. I'm up here, I'm almost sweating. This is some heavy math. So hopefully you're following along. If you need to pause the video, take a breather, do some meditation, whatever you got to do, keep a level head here. I know this is getting pretty intense. So check it out. We're trying to find this. We know that our denominator down here is 360. We're good there. Whoops. We actually already know the measure of angle CDB. We found it. Theta is the inverse sine of 1/4. So I'm going to go ahead and replace this with the inverse sine of 1/4. Now, the only piece that we're missing before we find the arc length is the circumference of our circle. So let's find the circumference of the circle. I'm going to erase this piece down here. The circumference of our circle, remember, circumference equals pi times the diameter of the circle. And actually right now we already know the radius of the circle. The definition of a radius is any straight line from the center of a circle to the circle's border, right? So actually CD is the radius of our circle, and we know that it has a length of 4. Okay, so if the radius, remember the formula for diameter is 2 times the radius, and if the radius is 4, the diameter is 8. That's the diameter. So now we need to find the circumference, pi times the diameter, so the circumference of this circle is 8 pi. Great. So now all we have to do to find the arc length is take our circumference and put it back up into our formula here. So let me go ahead and do that for you. I'll just go ahead and plug it in here. All right. So folks, the heavy lifting is done here. This is our arc length. Now it's just a matter of simplifying this down so that it matches one of our answer choices. Okay? Whew. All right, let's do this. You'll notice that if you look at all of your answer choices, it has the trig function kind of on its own, and then the other pieces make up the fraction. So if we were going to write this kind of in the structure of the answer choices, it would look something like this. It would look like, you know, inverse sine of 1/4 times 8 pi over 360. That's what it would look like if we wrote it in the structure of our answer choices. Great, so now let's reduce this fraction. Well, you could do this on your calculator, you know, 8 over 360. If you do that on your calculator, you get you get that 8 over 360 reduces to 1 over 45, right? So we got to carry our pi over as well. So 1 pi over 45 is just pi over 45, okay? So now we have this whole entire fraction simplified. And what we'll have is that the arc length is equal to the inverse sine of 1/4 times pi over 45. So this whole piece right here is your final answer. Pi over 45 times the arc sine, or the inverse sine, of 1/4. I know that's a doozy, but there she is.